All right, let's look at a couple of examples of integration by substitution. All right, so let's look at the first one. All right, so we want to evaluate this indefinite integral of 3x cube root of x plus x squared dx. All right, so let's do that. So whenever you have a square root or some parentheses, and usually the expression inside the parentheses or the square root cube root is going to be u. So I'm going to call this guy u, right? So let u be 1 plus x squared, right? Then we're going to take the derivative of u with respect to x. So du over dx is equal to, right, derivative of 1 is 0. Derivative of x squared is 2x. Right? Then I'm going to take the reciprocal of both sides. So basically I'm going to put it upside down. So dx over du, which is going to be 1 over 2x. Right? And the last step is I'm going to just multiply both sides by du. Right? So I'm just isolating dx. So dx is the same thing as du over 2x. Right? So we have that. Then I'm going to start rewriting. So this is going to be, right, so you have an integral. Right, I'm going to leave 3x as it is for now. So you have a 3x. Right, then you have a cube root. Right, then inside is u. So that's a substitution. Right, dx has a new way of dx is same as du over 2x. So I'm going to put the du over 2x. Right. Now we can cancel things. You can see that here there's x on top and x on the bottom here, right? Then also we have a constant 3 and on top and the constant 2 on the bottom. So I'm going to just pull those out. So if you pull it out, you can 3 halves is outside. Then you have an integral, right? And I don't like a cube root, so I'm going to rewrite it as 1/3 power, right? 1/3 power is same as taking a cube root, and the du, right? So that will take care of everyone, right? Because we took care of cube root of u, right? That's u to the 1/3 power, and there is a du, and everything else is either pulled out or canceled out, all right? So we have that. All right, this is just a power rule, so we should be able to do it without any problem. So it's going to be 3 halves is just a constant. Put it in front. Right here, power rule. Add 1 to the power. So 1/3 plus 1 is 4/3. Right? Divided by 4/3 is equivalent to multiply by 3/4. Right? Then plus some constant. C. Right? So this will give you the answer, right? So 3 times 3 is 9, right? 2 times 4 is 8, right? U is original expression is 1 plus x squared, right? Raise it to the 4/3 power plus some constant C, right? So that's the answer. Right? Be sure to put the original expression back in. You cannot leave the answer like this with u in it. You have to go back to the original variable, in this case x. Alright, so let's try the next example. Alright, it works pretty much the same way. So we have to find a substitution. In this case, we're going to use a substitution because e to the x would be, or e to the single variable would be nice. So this is kind of yucky here. All right, so I'm going to call that guy u. All right, so I'm going to call that guy u. So I'm going to just call this guy u, right? So go through the substitution. So the usual drill. So let u be negative 1 over x. Right? You can write it as a negative x to the negative 1. Alright, then we can just go ahead and take the derivative. So du over dx is equal to, right? So you have a negative sign, put the negative sign in front, so it's going to be positive, x to the negative 2. So subtract 1 from the power, right? So this is going to be just the 1 over x squared, right? So take the reciprocal of both sides. Since I'm trying to isolate dx, we want dx on top. So dx over du is equal to x squared, right? Then we can simply multiply through by the denominator du. We can write it dx can be written as x squared du. All right, so let's use that to rewrite it. So this is going to be integral, right? And we decided to call that u. So on top you have e to the u, right? And I'm going to leave the denominator as it is. So you have x squared, right? Dx is now x squared du. So I'm going to put in x squared du instead, right? Then we can see that we can cancel. There's x squared on top, there's x squared on the bottom. So we simply get integral of e to the u du. This is a very simple integration. Integral over e to the u with respect to u is e to the u and plus some constant, right? Then final answer should be, you just have to put the original expression back in. So it's going to be e to the negative 1 over x plus some constant c, right? So that's the antiderivative that we're looking for, and we could easily find them using substitution. All right, that's it. I hope that this was clear.